Yeah, allow me to take this opportunity to welcome you back at this other session of ours. We are still continuing with our topic, autotrophic what? Autotrophic nutrition. Please just follow and subscribe for more videos on autotrophic nutrition. So from after we complete autotrophic, we shall go to hetero, and then we move to what we call ecology. So sun and shade leaves. These are the two kinds of leaves we are going to talk about in this session. So I talked about sun leaves, and I said that if you have to remember, sun leaves are those leaves that grow on branches exposed to direct sunlight, while shade leaves are those leaves that grow on branches exposed to light that has passed through other leaves. Then when we continue, we are saying that in low light, plants need to maximize light absorption for photosynthesis to exceed respiration if they are to what? If they are to survive. We shall talk about that as we continue. Then in high light environment, plants minimize their capacity for utilizing abundant light energy, while at the same time dealing with the excess sunlight which can breach chlorophyll, as we looked at that one earlier. So let us go and look at the adaptations to photosynthesize in sun and shady environment. So when we talk about shade environment, so our first adaptation of shady plants, one is the abundant chlorophyll B. So we are saying that in shade environment, these plants which lives there have got high amount of chlorophyll B, in bracket chlorophyll A to chlorophyll B ratio, which gives leaves darker green color to increase light absorption in the dark. So we are saying, people, I don't know whether you have ever seen those leaves which lives under what? Canopies. Those trees under canopies, their leaves are darker green, and this is to increase light absorption in the dark. Then too, we are saying that the palisade stroke sponge mesophyll ratio is low to allow maximum light penetration. So another point, we are seeing that the mesophyll cell surface stroke leaf area ratio is low to maximize light trapping. Then when we talk about leaf orientation or leaves, leaf orientation is horizontal to maximize light trapping. Then the reddish leaf undersides to enhance reflectance back up through the photosynthetic tissue, giving the plant a second chance to utilize the light. Then from there, the stomatal density is also low to avoid over cooling. Then number 7, we are looking at thin leaves to minimize light penetration. That these leaves which lives in the shade environment are very thin, so this enables maximum light penetration. Then we are saying that the stomatal size is large to allow loss of excess water. That these plants which lives in the shade environment, they have got their stomata which is large in what? In size, and this is to allow loss of excess water. Then we have elongated internodes for increase the access to light. So these plants which live in shade environment, they have elongated internodes, and the importance of this is to increase access to what? To light. Then number 10, the chloroplast size is large to increase the surface area for storage of photosynthetic pigment. So those are some of the adaptation for photosynthesizing in shade environment or shady plants. Then from there, we are going to look at the sun plants. Under the sun plants, we are going to say abundant chlorophyll A, in bracket high abundant chlorophyll A in bracket high chlorophyll A to chlorophyll what? To chlorophyll B. So we are saying that sunny plants, for them they have abundant chlorophyll A and they have low chlorophyll B ratio. This is to increase light absorption. Then number 2, the palisade stalk sponge mesophyll ratio is high to minimize light penetration. Then number 3, when look at the mesophyll cell surface stalk, the leaf area ratio is high to minimize excessive light and transpiration. Then we talk about number 4 is the leaf orientation is elect to minimize light trapping. Then number 5 we are looking at it now. The stomato what? The stomato density is high to avoid overheating. Then number 6 is the match carotenoids to prevent damage to chlorophyll what? To chlorophyll A from very bright light. Then number 7 we shall look at the thick leaves to minimize light penetration. So when we talk about thickness of leaves, we say that those plants which lives in or under tree canopies, for them they have thin leaves to maximize light penetration. Now when we talk about sunny plants, for them they have thick leaves to minimize light penetration. Then number 8 we shall look at what we call the stomato size, which is small to minimize water loss, because these sun leaves, for them they receive light directly from the sun. Now other features we can look at the rubisco and the soluble protein content, or the mass is what? Is higher. The number 2 you can look at the chlorophyll stalk, the soluble protein ratio is also high. Then the chloroplast size is small. Then from there is also this part here where we are saying that the photosynthetic pigments in sun leaves and the shade leaves of beech tree. So of beech trees. Chlorophyll A, here we have photosynthetic pigment, then the other side the minimums of each pigment per meter squared of leaf area. Now we have sunny leaves and the shady leaves. So it is much in sunny what? Sorry. Yeah, sorry for that. So I'm now back online. Let us proceed with our lesson. So we are looking at the photosynthetic pigment, the minimums of each pigment per meter squared of a leaf area. Then you have chlorophyll A. You have chlorophyll A under sun leaves. It is more in sun leaves and less in shade leaves, as you can see. Then when we look at chlorophyll B, that one is they are abundant in shade leaves, as you can look at those numbers. Then we look at the carotenoids. Still, those carotenoids are more in sunny leaves, because these carotenoids prevent chlorophyll from being breached by excessive sunlight. So we are saying below there that graphically the data can be reflected by a bar graph. So from there, let us go ahead and look at the comparisons of distribution of photosynthetic pigment. So when you meet a question which is talking about comparisons, they are requesting you to give the similarities and the differences at the same time. Now the ratio of chlorophyll A to chlorophyll B is bigger in sunny leaves than shady leaves, as we've seen there above. So sun leaves contain more chlorophyll A than shade leaves, because Chlorophyll A is more effective at absorbing the light of wavelength available to sun leaves, e.g. about 450 nanometers. Then shade leaves contain more chlorophyll B than sun leaves because in shady plants, chlorophyll B improves light capturing capability of the chloroplast. Then the last bullet there, sun leaves contain more carotenoids than shade leaves because carotenoids are accessory pigment that shield chlorophyll from destruction by excessive sunlight. Then from there, yeah, this number is also common. They can ask why few species of plants can survive under shade habitats. We are saying number one, there is less direct light reaches ground via the gaps in the canopy, hence minimum energy is available for effective photosynthesis. That this light which passes through the gaps which has been left by the canopies, that light actually reach the ground with the minimum energy, so is available for effective what? Photosynthesis. Then of the light that passes through leaves, only a small range of wavelength reaches the what? Reaches the ground, which is not effective for what? For photosynthesis. So that right, that is the that condition is called transmission. We looked at it up there. So therefore, under shade habitats, little light energy is available for chlorophyll to absorb, and hence photosynthesis is insufficient for what? For growth. So allow me end here and wish you a good what? A good evening. So we shall start from there. I sign out.